Yeah. All right, we are live. Good morning to anyone watching the stream. It is officially May 22nd, 2023. And I want to document that yesterday, me and Mrs. GenesisGir, my fiance, we were going to reverse engineer this artificial neural network for the first time. It went pretty good, but I kind of took it kind of hard on her. I want to apologize to Mrs. GenesisGir for that, because it's an unrealistic view that someone's going to definitely get and understand and parse the idea of artificial neural networks on their first try. You know, sometimes I just want what's best for her. And again, we're going to try again today. And I'm not going to be so harsh. And, you know, everybody learns differently. And it just goes to show that not everyone's mind races 50 million miles per hour. And everyone's different, right? So the reason why I'm saying this is so if anyone out there has somebody that they care about or they love, or a friend, and they're not learning as fast as you, or you're not learning as fast as them, just know that everyone learns differently in their own way. And yeah, with that said, today we are going to be getting into the topic of artificial neural networks, right? And I'm pleased to announce that yesterday, me and Mrs. GenesisGir, we worked on our first neural network. Here it is. So it's a MINST digit recognition artificial neural network, and it's a pretty simple one, as you guys can see. And we're using TensorFlow. And what I'm going to be doing this entire stream is reverse engineering it, trying to get an idea of what these things do. I'm going to be doing it in cohesion with ChatGPT. To get a better understanding. So let me sign into email. Okay, give me one moment. We're going to be going over neural networks this stream. So, today we're going to be talking about, well, what we're going to be doing today is reverse engineering a MINST artificial neural network, recreating it over and over and trying to get an understanding of how it works. And that's what I'm going to be doing this stream. So for any documentation purposes, I'm going to be reverse engineering a project that ChatGPT has given me, and I'm going to be doing further analysis on this project, seeing if I can get a better understanding. Actually, for the first time, getting my feet wet with artificial neural networks, or ANN networks, or ANN, right? So I'm going to be making a template, and yeah, we're going to be calling this and templates. And inside here, we're going to copy and paste, and we're going to call this a MINST ANN template. And then we're going to delete all of the stuff within here. Now we don't want to go off of memory. What I might actually do, I'm going to create a version, import load modules, TensorFlow, and Keras, right? So we're just making a little template here so we can go off of. Yeah, I'm not even tired right now, but as you know, so this is the little template that we have going on. We have 1, 2, 3, like 7 stages. But one of the most important things is not to go off of memory. I'm going to be trying to, I've done pre-study before this. I have a ton of studies and like notes that I have taken on the topic of neural networks, and I've read a bunch. If there's something that I don't understand, I'm going to be going back and forth and reading. But to truly understand neural networks, it's definitely going to be, it's definitely a task that takes time, right? So if you want to understand neural networks and how they work, artificial neural networks in that sense, you do have to study over and over and over and over until you ultimately get a deep understanding about how this stuff works, right? So with that said, I'm going to go ahead and jump right into it, shall we? You know what I might do? I might actually code in 120 FPS. I'm not even going to lie. There's 120 hertz. I mean, there's, if anyone's wondering what type of hertz I actually code in, I code in 60 hertz. But check this out. This is the funny thing. My refresh rate can go up to 280. And some people would say, well, why don't you just use your extra hertz that you have to take advantage of it? You know what I mean? And here, let's see. Let's ask ChatGPT. If I have a 240 hertz monitor that can overclock to 280 to 80 hertz, but I choose to stay at 60 hertz to prevent it from breaking faster, stressing the system. Does using 60 hertz rather than higher than a higher refresh rate preserve the long-term lifespan of my monitor, or does it not matter? It does not affect the lifespan of the monitor, so it really doesn't matter. So there you go. There's the answer. It doesn't matter if I play at 120. It doesn't affect anything. So I can just stay at 240 for as long as I want. But for some reason, I choose to stay at 60 hertz. I don't know. Maybe it's because my eyes are so used to it, you know? Now, I think what else it could be, it could definitely be because maybe you guys can't see the 280. Now, maybe if you guys were able to actually see the 280 hertz refresh rate, then okay, then I'd probably do it more because now, you know, I get to show it off, but I mean, who else is going to see it? I'm so used to coding at 60 hertz. Now, there is a actual benefit. There's two benefits. Some people say that, oh, well, and I'm actually going to do it now, believe it or not. I'm going to put it up to a higher refresh rate. I'm going to code at, let's see, fuck it. I'm going to code at 280 hertz. And I'll tell you guys the benefits. Already I can tell right off the bat, the smoothness of the mouse, it's so smooth, and the input delay is way better. So I would actually say from now on, I'm going to use 280 hertz. And later in the future, I will get a higher refresh rate monitor. But yeah, one of the benefits of using a higher refresh rate as a programmer is there's less input delay. And you can actually, you know, move things faster, believe it or not, when dragging windows. Like if I were to take this window, yeah, it's just way more smoother in a way. You guys won't be able to see it because it's in 60. Unfortunately, on YouTube, it doesn't allow me to stream at higher FPS values. So there's that. Right? So right off the bat, I can notice that I can actually see my mouse trail way better. It's 10 times better. Now, my gaming monitor can actually go up to like 280. And why does this matter? Don't worry, these streams are going to be very long. I'm going to try to stream for as long as I can. We have 2 notification here. We just got followed and someone liked. But you could really do a lot. What am I saying? Let's actually get to back to the matter of task. Yeah. So yesterday, me and my girlfriend were working on our first artificial neural network, and we were reverse engineering a MINST digit recognition neural network that allows you to check and identify handwritten digits from the MINST dataset. So the MINST dataset, for the people who don't know, if we go to MINST dataset, let's go type in MINST dataset. I think they even have a website. So here's what kind of like the MINST dataset looks like. They're handwritten digits, and this was created by employees and high school students. They wrote it so they can actually work with neural networks, right? So let's actually go see visualization homepage. Okay, so here's actually, I think this is the official website. I'm not sure. Yeah, it feels way more smoother. Holy fuck, it feels way more smoother. Let's see. Yeah, but long story short, we created one. I'm not gonna run this one because the last stream, I deleted the last stream because I kind of went you know, teacher mode on my girlfriend at the end. So I deleted it, and then, you know, she's really talented. She has a lot of capabilities of doing a lot of stuff. She's a very talented programmer. I'm actually her mentor. So I actually went like full ape shit on, you know, because we studied for 2 hours, and then she couldn't tell me what was going on at the end. But I think it was just the information in her head was just brewing. So maybe today she'll be able to actually tell me what's going on. I'm hoping that. And if not, then I'm going to teach her some more stuff. With that said, we are going to go back here, and we're going to start breaking it all down. So we're going to import TensorFlow, and then we are going to, from TensorFlow, import Keras. Now, we're going to ask ChatGPT, why do we need to do this? Now, obviously, I know why we do this, but at the same time, you never know. My assumption is the reason why we import TensorFlow is because we want to use the method, functions, and framework from TensorFlow so we can actually create our machine learning algorithm, right? So that's like equivalent of saying, why do we need a stove and a pot to cook food? It's because we need it. So yeah. So now we actually have to ask ChatGPT. We're going to go back yesterday. I think this was what it was. Why do we need to do this? My assumption, I spelled assumption wrong, is, all right, so I'm going to go ahead and turn on music. Yes, your assumption is correct. The code snippet you provided, the import statements in TensorFlow and Keras are used to import the necessary modules, functions required for building and training a machine learning model using TensorFlow. ChatGPT is having trouble with this context. Okay, this is taking its sweet time. Let's try perplexity. Let's see if it gives us a faster answer. All right, so we're actually okay. We could just call this MINST dataset. Let's like mess around. Right? Just to get an understanding. Yeah, to see how this is still going. So we actually have to load it now. Train images, train labels. MINST.load data. We need to we have to load the data now. So the train images and we need the train labels. There we go. Let's see what's going on here. Okay, so what we're doing is that this load data returns two tuples, as we can see. This data set of the 10 digits. So it returns a tuple. Okay. Okay, let's actually put the path. Path is equal to stop NPC. Just to know what this is doing, right? Okay, so we're actually loading the images in here. Now we need to pre-process the data and normalize the data. So let's go see how to do that. So now we're normalizing the data. All this test images. So this is let's ask ChatGPT what's going on here. It's probably still going. I think this is going to help my girlfriend out a lot. rectified linear unit. And this one's using a softmax. Okay, so it is really useful to actually, even though it's optional to name the model, it is good to name the model because it says this line assigns the name to the model. The name is an optional parameter, but can be useful for identifying and referencing the model later in the code. We have models is equal to chars.sequential. This creates an instance of the sequential model, which is a linear stack of layers. The sequential model is a convenient way to build a neural network where each layer is added one after the other. Then we have Keras, and we have all this. Inside the sequential model, we define the layers that make up the neural network architecture. Oh, so these are the actual layers. So let's go ahead and put architectural layers. Where's architectural? Right. So here we have the architectural layers. We have the model name. We're just ripping it piece by piece, trying to get an understanding of everything. Architectural. Let's see. Wow, that's the neurons right there. $218 neurons. Okay, this is starting to make more sense. Okay, so essentially we are actually flattening the input images from a 2D array from 2820 pixels to And the loss function we're going to use. This is the loss function. No. Let's see here. This is a great way to reverse engineer and learn. Okay, we're almost nearing to completely finishing this reverse engineered MINST artificial neural network, and then we can run it and then you guys can see the results of what goes on. But we've broken it down. I've been breaking it down. Okay, let's go see. To evaluate the model, we need to test loss, test accuracy. All right, because now we're in the testing phase, so when you do the test loss, we're making 2 and test act equal to model dot evaluate. Inside here we have the test. Let's see, test images and test labels. Labels, and then now we go ahead and print test accuracy, Genesis model test accuracy. And we're going to put this, we're going to put test ac. Okay. Now. This is the evaluation stage. We're going to read, I'm going to read up on this. So far, we have imported the modules. We have loaded the dataset. We have normalized. We have defined. We have compiled. We have trained. We have evaluated. Generalization. I gotta check up on that. Okay, we could actually run this now. Because I read up on this. We broke it down. Let's actually see if we wrote first time's the charm, question mark. Okay, so we did something wrong here. It's just the name here. It works when I put it back down here. There we go. .97, as you can see. And we successfully did it. We successfully made a model that is the Genesis model. Test accuracy is 0.97. So this is just giving its accuracy. So we've successfully made a artificial... We made a model that is capable Did we? Hey, let's ask it this question. We created an artificial neural network using the TensorFlow and Cure libraries. An artificial neural network is a computational model inspired by the structure and function of biological neural networks, such as the human brain, and consists of interconnected nodes called the artificial neurons or units or perceptrons organized into layers. Yeah, but what if... Alright, so we can feed it data. How do I... Okay, now we're actually going to write some code to give us predictions on images. So we're going to go to handwritten digits. We're going to go to images. I don't know. Right? We're going to go to like images, like handwritten digits. It doesn't even matter. I guess like just digits. We can look up numbers. And we're going, like this image here, we're going to pre-process it and everything. And we're going to store the path to this specific one. We're going to see if this is a 9 or not with predictions using our model that we just created. And I'm going to figure out how to do that. So let's see. So here we have the test loss, and here we're doing that, but we could also do more. We could actually go over here. Load and pre-process the image, reshape the image. So there's going to be some steps here. We have 1, 2, 3, 4. So this is going to take 4 steps. I'm going to copy the comments. Pass the image through the ANN. So first things first, this is the creation of the neural network. And then over here is going to be the prediction. We're going to be doing the predicting over here. I feel like we should rename this. We could rename this. What are we in? We're in a template. So we can actually rename this to Genesis dash model. And we're going to call make models. I'm going to go ahead and put this in here. Okay. Now that we have this in here, we can make another file. Predictions. And actually, let's call it digit predictions. And we're going to import this model. Because in a sense, I mean, why would you have that? Why would you write the predictions there? I mean, right? So here we're going to actually import the Genesis. Let's see. Genesis. I want to import this module. Let's see. Because we are here. Let's see. Actually, say from models import Genesis. All right, that's not showing up. I'll be right back. Gotta use the bathroom. All right, this way, I have you muted, but this way we can yeah, we don't have to do it all on this module here. And I just found out to not put dashes inside of your module names because you won't be able to find them when you import them. So it's probably better to use underscores, I'm thinking. Yeah, I'm gonna start using underscores now because that was very strange, but okay, so here are the processes. So I have two. You don't have to worry about it. You don't have to feel stressed out. All right, so what was I gonna do? Okay, no, it's this one all the way down. All right, so we have 1, 2, 3, 4. And we have this. So we have successfully created the neural network. This neural network is a model called Genesis model, and we're importing it now to a different project, a different .py. And what we're gonna do now is actually use the model, right? We're actually gonna load and pre-process an image. We're gonna go to Google. We're gonna get an image, any image. We're gonna pre-process it. And once it does the pre-process, or known as normalization, we're gonna reshape the image. We're gonna pass the image to the ANN, to the artificial neural network, which is Genesis model. And then we're going to interpret the predictions. So what does interpret mean? We're going to display / interpret the predictions, right? So now this is actually being used. We're actually going to use it over here. We're going to run this. So that means we can take this all down. I made something for my girlfriend here so she can better understand. So I made a template, and in this entire thing, I've actually we've grabbed some synopsis from ChatGPT. So there's explanations of what everything does now. She can read through it, explaining literally everything's here. Now all she has to do is just study this, and this will help out. It's still convoluted, and the reason why I say it's still convoluted is because the reason is because you still have to do some studying. So I'm probably going to pass her this vault of, like, I mean, really, like, this is all the stuff that I've been studying on. Like, this blob here is, you kind of do need to read through this, and this is like 3 days, 5 work. This is like a lot of study, right? So I don't expect her to get it instantly. People learn at their own rate, and I tend to, and I'm streaming, that's why I'm talking. I tend to learn very quickly. So, I mean, I can't expect everyone to learn as fast as I do. So there's that. Okay. With that said, let's actually implement this. Let's actually test the model. Let's actually go ahead and go over here. It's I don't even think we have to train the model anymore. Let's see. Let's try to experiment. Let's see if we have to train the model. I already trained it once. Let's not train it at all. Let's just... Okay, so... I don't know why this is Flower Genesis. This is... Oh, this is an old one. This is the one. Train... I don't think we have to train it. Let's test it. Okay, so as you can see, you do have to train the model always. So you start getting bad results. So now we're going to start training it. So now this is the training process. Or you do have to train it. So now the accuracy goes up as it goes on and on and on through the epochs. You can see now the accuracy is 97 point. The Genesis model test accuracy is 97. I wonder how you can round things off in a calculator. I have a calculator here. I want to put this in, and I guess I just press enter. How do you round in a calculator? I don't usually use it. What function is it? Huh? No, what button it is? What button is it to round? Oh, here he is. Is this a round off value? Round off value to display precision. All right, so let's put this in and then let's enter and then round. Yeah, that didn't work. I'm in a calculator. I'm trying to, I want to get the absolute value of this. I'm in a calculator. I put 0.9758999999437. I want to round this off. I want to get like, I don't know, 97. So how would I do that? Constant. Okay, we're just gonna use Python. She's half asleep. You're half asleep right now. Okay. Okay, that was definitely not it. Okay, well, I don't know how. Okay, but when you wake up, you can tell me, okay? Because you're like asleep right now, and I can barely hear you. I'm gonna go back to this over here. Load, and now I'm actually going to load and pre-process the image and actually predict it. Okay, let's actually do this. Go see. So let's ask ChatGPT, where do I save the image? So it says to make your trained and predict the digit of an image you pass it, you can use these steps. Okay. Sounds good. Load and pre-process image. Read the image file and pre-process to match the format expected by your ANN. Resize the image by 28 by 28 pixels and convert it to grayscale. Excuse me? Huh? Hold on, I have to mute her. I don't know what she's doing. There. All right. So that's what we're going to do. That's what I'm going to do. I'm going to resize the image to 28 by 28 pixels and convert it to grayscale. So that's going to be the first one. So image underscore path. Let's go. So that's going to be the image path. Themes. And this is going to be the path to our image. So I guess, I don't know. Let's see. Let's go check. Let's, what's it called? Models. Actually, I don't know where. All right, so I'm going to have to put the images somewhere. Right now, give me a second. I have to figure out where to actually put these images first. We can just put them in. Let's see, where go here. This is Ann. Ann templates. Let's make a new repository here, and let's just call this Google Images. Right? Let's just call it Google Images. And now we're going to go to Google. I'm going to save this image. Let's see. Here. Let's just remove. Let's just say, I don't know, cat. Let's just call this cat. So anyone be like, oh, well, it knows the number because it says the number inside of the file name. But if we go in and we go ahead and we read the properties, there's nothing that says 9 here. Security details. It says 8 here. As you can see, this is going to be the image we're going to be processing. We'll see if it'll know. I'm actually very curious. It could be wrong. It could be right. Who knows? We're going to go to Google Images. So you can see this is going to be the image. I wonder if I can shift right click. Copy relative path. And there we go. All right, I'm going to unmute her. Hopefully she's awake and cognitive. You alive? Hello? Okay. Let's see. Now, the next thing, we still got some more stuff to do. So we loaded the image. We still got to pre-process the image now. I'm going to close all this stuff. So we're going to do image.open image path.convert L, convert to grayscale. So this is converting it to grayscale. So that I've never used this before. So image.open and then convert. So we're using the image function. Okay. It's equal to image.open. Okay. Okay, so we are going to need this. And import numpy, because I think we're going to need that. So now image.open no, we don't have to do that. So this is going to be the image path. We're going to store the image path here. And after that, we're going to .convert. And then it seems like we're going to use L for some reason. And then this is actually converting it to grayscale. So black and white. Okay, then we have another thing here. After that, we're going to resize the image. Okay, easy enough. Image resize is that. Okay. Image.resize, and we're going to resize it by a tuple, right? 28 by 28. I could be wrong about this. No, I got that right. And we're resizing it to 28 by 28 pixels. Next, we are image normalizing. So it's going to be np.array. Okay, it says np is not defined. Strangely enough. Okay. See if I got this wrong somehow. np dot array. Let's just, okay, it says np is not defined. Oh, as np. Oh, so we got to use numpy. Okay. numpy.array. So this is the normalization. numpy.array and then the image divided by 255.0. This is my first time doing this. So let's see. So now we're normalizing the image. Or normalizing the pixel values. Okay, now we have to reshape the image. Dot reshape. Okay. And it seems as if it's going to take 1 and 170, what? 184. No, 784. All right, so now we're reshaping the image to a 1D vector. Okay, great. And then now we pass the image through the AND. So this is us actually passing the image to the AND. So we've loaded it, we've pre-processed it, we've reshaped it. Now we're going to pass the image to the artificial neural network. So we're going to make a variable called predict predictions, or let's call it predictions equal to model dot add loss. Oh, as you guys can see, here it is. Look. There's all the stuff there. Dot predict. Look, there it is. And then what we're going to predict is the image here. And then now we're going to display the image. So predict underscore digit. Okay. Oh, so this is predictions. Let's call this predictions. So this is where the predictions will live. Okay, that makes sense. So now we have to interpret the predictions. We're passing. And then we're interpreting the predictions. So let's not say display. So predicted digit. All right, so this is going to be the predicted digit is equal to numpy. I think that's num because it's using numpy. Argmax predictions. Okay, so this is okay, great. Now we actually display. Now we print the predicted digit, right? Display prediction. Okay, here we are. And then now we have this concatenation of madness. But long story short, what this is going to do, let's break it all down. We have the image path. We're actually importing the Genesis module. We're not really using this here. We can just... We're importing numpy, whatever how you say it. We're importing the Genesis module, my artificial neural network that I created. Then we're importing the model. We are from pill import image. We need this image, and if you guys don't know what it is, it's a module. It seems as if image has a lot to do. It's a function that has to do with manipulating images. We're setting the image path of the image that we want to use. It's called cat PNG. I changed the name so there isn't any discrepancy. So people would so there is a discrepancy between the actual picture and the name. So people won't be like, oh, well, it's name the name of the PNG is 9, so it's going to be 9. No, I literally named the picture cat, so this should be. There's a discrepancy between the two. And then we're actually converting it to grayscale. We're just making the image black and white. We're resizing the image to 28 by 28 pixels. We're normalizing the pixel values. We're dividing it by 255.0. That's a floating point number. And then we're reshaping the image. We're reshaping it to a 1D vector. Don't really understand this part here. I want to go study that. And then we're passing the image through the Genesis model that I created. And then we're going down to interpret the predictions. So the predicted digit is equal to numpy.argmax predictions. And then now we're actually going to display the predicted digit. Now, ladies and gentlemen, we're going to run this. We got a lot of shit going on in cohesion with one another. We have the actual artificial neural network here. This is where it is being built. And then we have a separate module here that takes an image. And the image we're going to be using right now is this number 9. And this is going to be the first time me testing this out. And I can't wait. I literally can't wait. So let's see what this does, shall we? Let's go see. If it outputs 9, I am going to be very, very, very impressed. Output. We might get an error. We might not. I don't know. We're running it. Epoch. It's going through its thing. Oh, it's doing it over here too. It's going through epochs. Okay. It's going through 5 of them. Here it goes. Let's see. Accuracy. Okay. Okay, so already off the bat, we have a value error in user code. The prediction function, run step, prediction. Okay, so it's telling us value error. Input 0 of layer Genesis model is incapable with the layer. Shape none, 21, found. So let's go give this to ChatGPT and let's go see what it tells us. Let's give it a shot. To resolve this issue, you need to reshape the image before passing it to the model prediction, the predict function. So reshape the image from 1, 20, 28. Wants us to do it this way. Okay, sometimes ChatGPT can be wrong. Reshape. So let's try this. Now it's like these values. Let's try these values now. Okay, we're running it. Running it. Do. Okay, so now it's actually giving us an actual thing. It says the predicted digit is 6, but as you guys know, no, then it's not. It says warning. Warnings.warn. It says predicted digit is 6, but it's a 9. As you guys can tell, so it was wrong. As you can see, that's strange. Predicted the wrong number. Upside down. You got it upside down. So maybe this is just a parameter set up. It predicted 6, but it was a 9. If the model predicted a digit incorrectly, such as predicting 6 instead of the digit 9, there are several factors that contribute to the misclassification. Here are some possible reasons. Insufficient training data, model complexity, hyperparameter tuning, such as learning rate, batch, blah, blah, blah. Okay, let's try another image. Let's try this number here. Let's try the number. Well, it has to be handwritten. Right? So it has to be a handwritten number. So let's try this one here. Actually, let's try this one. This number here, number 5. Google Images. And let's call this some num. You know, I mean, because it's trained on handwritten stuff, and that looks too clean. That could be it. So we're gonna keep that there actually, just to show an example that. Without a shadow of a doubt, this is gonna work. This is gonna be 5. Let's see. So we've actually created a neural network that can actually predict handwrite. So I might even later write some numbers down on a piece of paper, take a picture, and see if it can predict it. Okay, that's not good. That's predicted 7. So this model is predicting the incorrect digits right now. So let's go see. It thinks that it's 7. Let's try another one. Let's try this. Let's try this here. Because we're using images that are transparent. So let's try not using images that are transparent, that have a solid background. Solid num. Okay. Let's use this one here. No, that's not a 3 either. So far it's getting a lot of, it's been getting everything wrong so far. So let me try going into the MINST dataset. I don't know. Let's pass it this blurry one. I'm just gonna try everything at this point. Alright, let's try this. I'm wondering if I have to put these images inside the actual... No, that's not how it works. Hey, okay, it got that one right. 7. And in turn, yeah, that is a 7. So you guys can see. The first correct value. Let's try another one. Let's try this 3. Actually, let's test its consistency. Let's run it again. So right now we're doing sample image, and sample image is this one here, which is the 7. So I'm actually curious if it'll get it correct again. All right, let's go try. Okay, it got it right again, as you guys can see right here. Predicted digit 7. And yes, then the digit is, in fact, a 7. Let's try it with another one. Let's pass it some more values. Let's go see what else we can work with. Let's see what it's working with. Let's see what... okay, as you guys can see, this is obviously a 3. And we're going to throw it, pass it to the neural network and see if it could figure out the number. And I have a question. I wonder, by us passing it these values, does it help it learn too? Or it just goes off the data set? Actually curious. Now we're working with artificial neural networks now. Mrs. Genesis would be proud. Even though she's sleeping weepings right now. Alright, here we go. Going through the epochs. Actually, close. Let's try it again. Zoom in. You guys can get a look at it. It's going through the epochs. It's going through the training data sets. Through the training sets. Or set. It is in fact a 3. There we go, ladies and gentlemen, it is a 3. But for some reason it does not work with... Let's ask, does this only detect... what's it called? Let's go see. Does this only detect? Oh, from the MINST dataset. Okay, so I just learned something new. This artificial neural network is only... So whatever you train it on is what it's going to learn. So hopefully this will clear things up for everyone. So technically, when you train an artificial neural network, an ANN, the data set that you are going off of is crucial to what it's going to detect and what it's going to predict. So we are training it with the MINST data set. So it's only going to be able to predict patterns and shapes from the MINST data set. Let that be very clear. So I got really confused when I said handwritten digits. So it's MINST digits that were handwritten. So we can go to any one of these sites. And we can, you know, as you can tell, we have a 3, we have a 7, and so on. And it'll be able to predict this. I wonder if they have a site where... I wonder... These images. Here, let's actually go to the actual website itself. Train images. All right, so training set images and bytes. 4 files. Okay, it is a good database for people who are trying to learn. Okay, the MINST database of handwritten digits available from this page has training set of 60,000 examples and a test set of 10,000 examples. It is a subset of a larger set available from MINST. The digits have been size normalized and centered in a fixed size image. It is a good database for people who want to try learning techniques and pattern recognition methods on real-world data while spending minimal efforts of pre-processing and formatting. 4 files are available on this site. So we have the train images, the train labels, the images themselves. Please note that your browser may uncompress these files without telling you. If the files you download have a larger than above, they have been uncompressed by your browser. Simply rename them to remove JSON. Right. Many methods have been tested with this training set and test set. Here are some examples and details of methods are not given in an upcoming paper. Okay, so this changes everything. So let's download the images. Let's go download the images and I don't know what a .gz file is. So I think we can uncompress it. Okay, yeah. So downloads, we're going to extract. Okay, so this is a different type of file. It's an index, so that's not what we want. See what this does. Okay, so there definitely is some different type of file formattation. Okay, but yes, we successfully have created a artificial neural network that has the capabilities of detecting any MINST handwritten digits. It's done. With this, when my girlfriend wakes up or comes back from work, we can actually build up upon this and remake it from scratch and just practice this over and over and over and over and over. Because there is some stuff that comes into it. With that said, I'm going to go head out. I'm probably going to go play, I don't know. Watch some TV, get some food, get some breakfast. And with that, catch you later. And also, if you guys look at my description of my video, it'll say that I'm at the NASA Mission Control Center. That is a joke.